Hi, my name is Josh Margolis. I'm an environmental markets professional. Today we're going to walk through an emissions trading simulation which will show you how cap-and-trade programs can be used to deliver results for both the environment and for the companies that are involved in the cap-and-trade program. We're going to start with an introduction to how cap-and-trade programs are designed, the different component parts, and then we're going to move on into the carbon simulation itself. First, I'd like to thank a number of different entities, including UC Santa Cruz, which have helped us create this tool and deliver it to you today. Also, I'd like to thank EDF, the World Bank, the province of Quebec, AIDA, ICF, Mexico CO2, and a number of other entities that have helped create this tool and make it accessible. In this carbon market simulation, you will be running a company that's subject to an emissions trading system. The company is manufacturing product, power, metals, cars, cement. It's doing well. It's a profitable company. The government has said, we'd love to have you keep on operating, but we're going to reduce your emissions over time. Your emissions will start here, and they'll go down each and every year. Your emissions allocation will be less than your emissions itself. So if your emissions are here, your allocation will be smaller. That's a shortfall. Your job is to solve that shortfall at the lowest possible cost. This simulation is born out of lessons that we have learned from cap-and-trade programs over the course of the last 45 or 50 years. Lessons that we've learned from the Regional Greenhouse Gas Initiative, from the California cap-and-trade programs focused on criteria pollutants, from the EU ETS, from the acid rain program, from the Chinese programs designed to help the pilots, the provinces and the cities, which are serving as laboratories for the national cap-and-trade program. We've taken these lessons about how cap-and-trade programs work, about what works and what doesn't work, about weaknesses and strengths, and we've tried to drop those lessons into the simulation tool itself. The simulation tool is one that we've run through a number of different countries, in China, in Mexico, in Chile, in Thailand, in the US, and Canada. And we learned every time we run the simulation, we adjust it, we learn from you. So I'd really like to hear from you as a result of your experience in this cap-and-trade simulation. Tell me what you learned from this, what worked for you and what didn't. And then we'll try to make the simulation better next time. The Carbon Sim tool is an AI, artificially intelligent, enhanced, multilingual, multi-user, capacity-building application. It teaches emissions trading principles. It brings markets to life. It demonstrates that results are driven by design. If you want a cap-and-trade program that delivers reductions by the year 2030, then design it. Make sure that it, in fact, does do that. If you want a cap-and-trade program that generates revenues, we can design a program that does that. If you want one that, in fact, delivers equity and social justice, we can design a cap-and-trade program for that purpose as well. Carbon Sim demystifies carbon portfolio management. If you're a company and you're faced with an obligation to reduce your emissions over time, you have a number of different choices. The Carbon Sim application will show you what those choices are, how to build and run and operate a company, and how to use a carbon portfolio management approach. It's a platform for experiments. It's a platform for policymakers and for those who are subject to the cap-and-trade program to try out different approaches, to learn from those approaches, and to make mistakes along the way so that they can then take those mistakes into account as they come up with the next better version of how they're going to either develop and implement a cap-and-trade program or operate within a cap-and-trade program. You're going to understand what it takes to participate in a marketplace. A market is quite exciting. It's one where you're going to feel the opportunities to comply, but have fun doing it. You're going to manage a budget. You're going to be competing with your own best version of yourself as well as your colleagues. You're going to find out what it takes to comply at the lowest possible cost. You're going to cooperate. You're going to collaborate. You're going to compete. This is an exciting process. It's going to get loud in the simulation. You're going to find yourself excited to the point where you say, you know, I never had this much fun learning about how cap-and-trade programs work. But you're also going to find that markets will be taxing. It's not for everybody. That's one of the reasons why it's good to have a teammate. Today, you're going to be a little confused. There's going to be a lot of numbers on the screen. On the screen, you're going to see numbers about the budgets that you have, carbon budgets as well as your capital budgets. You're going to see numbers about the different technologies. You're going to see a number of different screens. You're going to be confused, and you're also going to be relieved that you're on a team. Because as confused as you are, you're probably thinking to yourself, my teammate probably gets it better than I do. I'm going to rely upon him or her, but together we're going to be stronger. You will learn from each other as teammates. You will improve your ETS literacy, your emissions trading system literacy. You'll understand what a cap is, what an allowance is, what an offset is, what a penalty is. You'll understand what volatility management means. All sorts of terms that will allow you to climb the learning curve. And with these terms in hand, you're going to be better prepared to both understand what is being told to you about emissions trading systems, and then to challenge it if you don't believe it and say, you know what, I think an emissions trading system to deliver the results I want should be designed differently. I think you're going to be impressed with yourself. None of you have likely ever bought or sold allowances or offsets. None of you have probably ever administered a cap and trade program. Today, you're going to be in a position as you finish the carbon simulation, you'll be able to say, you know what, I get it. I know how these systems work. And I think I can advocate for my interest the next stakeholder meeting that I'm involved in, where somebody says, what do you think about a cap and trade program? You're going to learn how to optimize marginal abatement control cost curves, how to optimize them relative to the marketplace. Don't worry about this terminology, a MAC curve. A MAC, we'll get into that a little bit later. You'll understand what it means, though, and how it's a powerful tool for you to use as you approach the market. You'll be able to connect design, capacity, and outcomes. You want a cap and trade program that delivers reductions, jobs, energy security? We can do that. We just have to design it right. You'll understand how capacity is necessary to make programs work. What I mean by capacity is training sessions like this. We have to train people to understand how to administer cap and trade programs and operate within them. And when we do that, we will have more efficient and effective programs. You'll see how if you have an effective design and you have capacity learning as well, that you will have outcomes that you like. You'll be able to connect markets to your studies. You'll see how carbon markets work for sure, but the principles that we're going to go through, they apply to any other kind of market that you might be involved with. And I think you'll be a more savvy consumer and you'll be a more effective market participant as a result of the simulation. I think you will have fun, and I think you're going to want to play again. Today, you're bringing some anxiety here because you've never participated in a carbon simulation. But let me give you assurances that thousands of people have gone before you. People from Duke, Yale, and Columbia, the UCSB Bren School, Georgia Tech, a high school in San Francisco, companies in the US, China, Mexico, Korea, Thailand, Canada. You have a lot of folks who have gone before you, and there's one thing that they share in common. None of them have participated as a full-time basis or actually likely have any experience in cap and trade programs, in designing cap and trade programs, in complying with them. So when you see the initial screens and it starts to get confusing, trust me, you're going to have fun just like the folks on the screen are looking like they're having fun as well. First, we're going to go through the emissions trading system basics, how cap and trade programs work, the different component parts. Then we're going to use that understanding to go through the carbon sim basics, the different component parts of carbon sim, what you're going to do when you play the game. Then we're going to have an open hand round. I'm going to show you how a company will make decisions, how you're going to make decisions, how you're going to read the screens to build and manage your carbon portfolio. Then we're going to start with year one. Year one is going to be an abbreviated year. Over the course of 20 minutes, you're going to have an entire year compressed. And during that year, you're going to have a company that starts with emissions that is greater than the allocation. There's going to be a shortfall. Your company is going to grow over time. It's a successful company. So the shortfall is going to grow over time. Your challenge is going to get greater over the course of that year and from year 1 to 2 to 3. We're going to stop at the end of each year, see how you're doing. We're going to review exactly what happened with your company as well as for the entire system. And then we're going to talk about the results. After we go through year 1, 2, and 3, each year being about 20 minutes in length, we're going to talk about what happened during the course of the simulation. And then we're going to have a post-game discussion. What have you learned? What worked? What didn't work? What surprised you? What can you take away from this for your studies? The schedule is going to look something like this. 3 different years, each year being 20 minutes in length. In each year, before you start year 1, you're going to want to put on abatements. Abatements are technologies that help you to solve that emission shortfall. Your emissions are here, your allocations are here. If you put on an abatement, you can solve that shortfall and bring your emissions down. You can probably solve your entire shortfall with technology, but you wouldn't want to do that because it's too expensive. Use technology as well as the marketplace. There are going to be 4 auctions in the course of every year. Auctions are going to run rather quickly over the course of 2 minutes and 15 seconds. Then there's going to be an interim time period between auction 1 and auction 2. Auction 2 is going to start then. You're going to have a chance to put in a bid into the auction itself. And then the auction 2 will close, you'll see the results, and you'll have an opportunity to see what happened and participate elsewhere in the market, and then go to auction 3 if you'd like. There'll be another pause, and then you'll go to auction 4. There'll be another pause, and that year will close. Now, while these auctions are going on, you'll also have an opportunity to participate in exchange trades. An exchange is where there are multiple bids to buy and offers to sell. You can participate in the exchange while you're doing the auction itself. You'll also have the opportunity to do over-the-counter trades. Over-the-counter trades are where you're trading with your other competitors, your other colleagues in the room. If you're long, that means you have more tons than you need. You can sell those excess allowances or offsets to another student elsewhere in the room if you can come up with the right deal. And then at the end of each year, we're going to talk about what happened and the lessons that can be drawn from this process. Carbon Sim Part 3, ETS Basics. The cap on emissions. That's the total quantity of emissions that companies involved in the cap-and-trade program can emit. The government decides that based upon the information that the scientists have told them relative to the carrying capacity of the environmental basin that you're in. The cap can't be exceeded. Over time, the cap will go down. Emissions will start high, and then they're going to go down year after year. That's the way we achieve environmental results. Without the cap, we can't be sure that we're going to reduce emissions. For a cap-and-trade program to work, we need to have a strong, effective cap. Cap and trade. The trade is the other element of the cap-and-trade program. In trading, we have a seller who's been able to reduce their emissions. They've been able to do that by putting on new technologies or by switching on operations. A buyer is able to buy these emissions. The buyer pays the seller money for these emissions reductions. Between the buyer and the seller, emissions don't increase. The seller reduces the emissions. The buyer increases. The buyer delivers money to the seller. The seller uses that money to put on more technology or to pay its workers or to create a more sustainable operation. That's the second element of cap and trade. When policymakers think about their environmental objectives, sometimes they'll think about the goals first. They're thinking, what am I trying to achieve? What's my objective? It's not, frankly, to create a cap and trade program. That's not their objective. It's not to facilitate trading. It's not to put a price on carbon. You know what the goal is? What's the goal that comes to your mind? I'm hoping that carbon reductions, that might be the top goal. How am I going to achieve the emission reductions that my scientists tell us that we need to achieve? Another goal could be improving the health benefits, to deliver health benefits to my workers, to my population, to reducing morbidity and mortality. That's a goal that's worthy of a program. Creating jobs. Yeah, I want to create jobs with this program. I want my economy to be more sustainable. I want to increase the number of jobs and to increase the viability and the sustainability of those jobs. I want to have a more secure energy supply. I don't want to be subject to disruptions. I'd like my energy supply to be greener and more secure over time. I'd like to have more equity in my society. Those entities that are suffering from the pollution from the past, I'd like to deliver to them some monies that can be used to improve their lot in life, to give them better schools, to give them better transportation, to give them cleaner air. I'd like to have a fairer system, a system that delivers that's based on fairness. And I probably have a number of other goals. These are the goals that should drive me when I say, what kind of a program do I want? And when you're developing a cap-and-trade program, they should design how you think about cap-and-trade programs in terms of the component parts. The allocation, who gets what? This is a decision that policymakers can decide. Whether or not to use auctions. Should they be cost minimizing or maximizing? How frequent should the auctions be? How big is the cap? Should it be reduced gradually over time? Should this cap-and-trade program be linked with other cap-and-trade programs? Should there be market monitoring? Of course there should be market monitoring. How do we make sure that people don't cheat? We need to have systems to monitor companies and individuals who are participating in this system to make sure that we know what they're doing, why they're doing it, and we have a means of catching those who are looking to game the system. We have to have a system that incorporates new sources. Sure, we are developing a cap-and-trade program for the existing companies, but we want to grow this economy, and we want to make sure that the new sources who come in don't increase the problem. So we need to find a way to incorporate them into the cap-and-trade program. Offsets. Offsets are emission reductions that occur outside of our cap-and-trade program. We want to make sure that offsets are allowed and that they are encouraged, because if we encourage offsets, we can get reductions from those who are not included in the cap-and-trade program, and we can also keep prices down. Penalties. Absolutely necessary to have penalties in a cap-and-trade program, penalties that are high enough to discourage people from trying to cheat. You need to understand that if you cheat, you're going to get caught, and it's going to be very expensive. The penalties have to be sufficient to discourage bad behavior. Yeah, there will be a price on carbon. We will be able to see through the various mechanisms here what carbon costs through the allocations, through the auctions, through the exchange, the over-the-counter trades. You'll get a report card from your boss, from the environmental entity, the organization that's running the cap-and-trade program, that will tell you how much you're spending relative to others that are engaged in the cap-and-trade program. Scarcity. If you want to achieve reductions, you have to allocate scarcity. That means that if the emissions are here and you want to bring them down to here, you can't over-allocate, because if you give people more allocations than they need, they're not going to reduce their emissions. You want to reduce that budget over time. You need to make sure that folks understand that emissions will be reduced because the allocations will be reduced. It's only with scarcity that we can achieve those environmental objectives. So the scope of the program, who's included in this cap-and-trade program, which sectors are included, and what kind of reductions are going to be required from the different sectors that are included. And we also probably want to think about volatility management, which means how are we going to monitor and keep prices from wildly fluctuating over time. These are some of the parameters that you're going to be thinking about when you design a cap-and-trade program as a policymaker. There are a number of others. All of these parameters can be adjusted in the carbon simulation that you're about to experience. From the industry side, why would you want to participate in a simulation? Well, when you're faced with emissions and an allocation, that allocation is less than your emissions, an allocation of allowances, you need to have a ton of allowances for every ton of emissions. So if your allocation is less than your emissions, there's a gap. What do you do when you're faced with that shortfall? Well, you have to balance. You have to decide, do I reduce my emissions on site? Do I participate in the marketplace? If I'm going to reduce my emissions on site, I have a number of different choices. I can make my operations more efficient. I can do process changes. I can switch fuels. I can put on new controls. If I go to the marketplace, I can participate in the different auctions or the exchange. I can do over-the-counter trades. I can buy emission allowances or offsets. I can buy and sell these. These decisions that you're making, this is where your carbon portfolio management strategy comes from. You're going to be creating your own carbon portfolio management strategy. You're going to be adjusting it over time in response to what you're doing on site as well as what the market is doing. Carbon Sim, Part 4, Carbon Sim Basics. In this simulation that you're participating in today, there are two kinds of players. There's you. There's your colleagues. There are other students who are also signed into the system. There's also the AI-driven bots. These are bots that are designed to make this simulation more realistic. Everybody who has access to a laptop, you're signing in and you're participating, you're managing your own companies. These artificially intelligence-driven bots, they're also managing companies. You're going to have an opportunity to see how they operate. They're driven, like you, to comply at the lowest possible cost. You're going to be able to trade with an AI bot. Here's the thing about the bots. There are more of them than there are of you. To make this more realistic, we'll have 240 different entities, up to 40 of which will be humans. The rest, they're all AI bots. That's the way we make the system more realistic, because if we had a cap and trade program with just 40 companies or 20 companies or just the number of students who are signed into the carbon simulation, it wouldn't be very realistic, nor would it be a prudent use of resources. So we have the bots to make it more interesting and more realistic. When you're faced with the emissions shortfall, the allocation shortfall, your emissions are here, your allocation is here, there is a shortfall. Remember, you have choices to make as you put together your carbon portfolio. You can reduce your emissions on site by changing out the fuel you use, by putting on controls, by making your operations more efficient. These are choices you can make to reduce that shortfall. Emissions are here, allocation is here. You can put on technology to reduce that shortfall. You can also participate in 4 government-sponsored auctions. The auctions are run as sealed bid uniform price auctions. I'll tell you about how they work in just a minute. You can also participate in an exchange. An exchange is where we have multiple bids to buy and multiple offers to sell, all at the same time. And you can put in a bid to buy or an offer to sell yourself. And you can buy and sell allowances and offsets through the exchange. You can also do over-the-counter trades. Over-the-counter trades are bespoke deals that you negotiate with other students. You can't trade with a bot, but you can trade with a student in the over-the-counter trades. You will be competing with bots in the auctions and the exchanges. So you have 4 options. You can control your emissions, reduce that shortfall. You can participate in 4 government-sponsored auctions. You can participate in an exchange, or you can do over-the-counter trades. First option, you can control your emissions. You can reduce that shortfall. You're going to be given a company that has a number of different technological choices. Choices that include reducing emissions by putting on new controls, by changing fuels, by putting on new technologies. Each technology here is represented by a bar, A, B, C, D, E, F, and G. The technologies on the left-hand side, A and B, for example, they're pretty inexpensive. In fact, you might even be able to save money. Those further to the right, C, D, E, F, and G, they're more expensive. All right? They're available to you, and you should think about them in the context of your own operations as well as what's going on in the marketplace. All right? When the market price for allowances and offsets is high, you should control and sell perhaps the excess allowances that you're generating. If the market price is high relative to your opportunities, then put on controls, because you can create tons of reductions for less than what the market is selling for in terms of allowances. And if you can create allowances for X and the market's selling for 2X, then you can make a profit by selling those surplus allowances into the marketplace. But conversely, when the market price is low, when it costs you this much to put on technology, but the market is selling for it down here, don't waste your money by putting on technology that costs more than what you can buy in the marketplace. Save your money and buy allowances instead. All right? A couple other things I need to tell you about the technologies. These are technologies that cost money. Your money. You're going to have a carbon budget and a capital budget. You need to make sure you have enough money to pay for these technologies. You also need to make sure that you understand that once you make this investment, you can't get it back. You can't undo the technology. If you spend $1 million to put on controls, you can't say, oops, never mind, I didn't mean to do that. You've spent that money. You can't get it back. Another thing to think about, it takes time to implement these technologies. From the time you say, do it, to the time that the technology is built and operating, can take anywhere from 3/4 of a year to 5 years. All right? So understand that it makes sense to make these decisions early on in the simulation process. Don't wait to abate. Do it early or not at all, so you can control right before the simulation starts. Or you can participate in 4 government-sponsored auctions. The auctions are run by the government using allowances that they have held back. Remember, you started short? Your emissions were here, your allocation was here. Well, the government took some of that difference and said, you know what, we're going to hold that back, and we're going to make it available to the marketplace, to you, through 4 government-sponsored auctions. In this particular example, the government held back 125,000 tons. All of the rest, the free allocation in blue, that was given out to you and your colleagues and to the bots. So let's talk about how this government-sponsored auction is going to work. It's a sealed bid, uniform price auction. Sealed bid, that means think about what you want to pay for these allowances that you're going to buy from the government in the auction. But don't tell anybody else. Uniform price. That means that everybody who's successful in this particular auction is going to pay the same price. Sealed bid, don't tell anybody. Uniform price, everybody pays the same price. So here's how it's going to work. The simulation is going to say, okay, the auction starts. You're going to get an indication. Remember, the auction goes for about 2 minutes and 15 seconds. You're going to have to think about a bid that you're going to submit, a bid to buy. The bid consists of 3 different elements. The product you want to buy, year 1, 2, or 3. The volume you want to buy. How short are you? If you're short by this much, do you want to solve that shortfall with one bid in this auction place? All right? If you're short by 100,000 tons, would you like to buy 100,000 tons? The third element is the unit price. How much per ton do you want to pay? All right? You can put in multiple bids. You can say, you know what, if I can get the price at a low price, if I can get these allowances at a low price, I'm willing to buy more. But if I have to pay a higher price, I'm going to reduce the volume that I'm going to buy. I can bid for year 1 or year 2 or 3 allowances. All right? Here's how the auction is going to work. So the auction closes. 2 minutes and 15 seconds. I went by really quickly. The computer takes a look at all of the bids that have been submitted, ranks the bids highest to lowest, unit price. Right? It says the unit price that we're most focused on is the highest unit price. We're going to put that one first, and then the next one, and the next. And then it's going to try to clear the bids based upon that unit price. In this particular example, we see that the highest bid that came in at 60 pesos per ton for 15,000 tons. If this was the only bid, the auction would clear at 60 pesos for 15,000 tons. That would be the only one. But there was another bid that came in at 59 for 10,000 tons. Between the two, we have 25,000 tons in aggregate demand. If this was the only 2 bids, the clearing price would be 59. A third bid came in at 58 for 10,000 tons. In total, between those 3 bids, we have 35,000 tons demanded. The computer keeps on going through this process, ranking the bids highest to lowest until it finds that it has been able to sell all 125,000 tons that were initially made available by the government. And the clearing price here is 45 pesos per ton for 125,000 tons. All of the bids below 45 don't trade because they're below the 45 peso unit price. And these particular buyers, they're happy that they don't have to pay anything more than 39 pesos or 37 because they're not interested in transacting at prices higher than their bid prices. Your goal is to buy tons at a price that you think is a good price, not a price that you think is going to clear the auction. You should not pay more than you think you need to pay given your own opportunities on site as well as what you see in the marketplace. So in this particular auction, we had 125,000 tons in aggregate that sold at 45 pesos. We have a number of other unfilled bids that did not buy allowances. Right? They had better opportunities elsewhere. All of the winners paid the same price. Everybody who bid 45 or more paid 45. The bidder who put in $60, they paid 45. The bidder who put in 47, they paid 45. Everybody pays the same price. The auction here is designed to minimize the price that you have to pay in order to be successful in this auction. The government could have said, you know what, we're going to design an auction that's different than that. You're going to pay what you bid, and that would increase the amount of revenues that the government would collect. But that's not the objective with this auction. The objective is to make the tons available at the lowest possible price and to provide a price signal, right? So there are 4 auctions. You'll have a chance to participate in auctions 1, 2, 3, and 4. Don't worry if you missed the first one. You can always participate in the second, the third, or the fourth. Moving from the auction to the exchange. The exchange is a marketplace where there are multiple bids to buy and offers to sell, all being processed at the same time. It's an opportunity to trade in between or during the auctions. How does it work? Well, on this screen, you see bids to buy on the lower left-hand side, and you see offers to sell on the upper left-hand side. The far right-hand side, you see historical trades that have already occurred. Let's go back to the left and focus on the bids to buy. The computer ranks the bids by the unit price. The highest unit price is the best unit price. It's the best bid. Here, the best bid is 15,000 units of allowances that are sought for 45 pesos. Below that is a 35,000 ton bid for 43.90. Below that is 15,000 for 42.10, right? And on down. Conversely, if we look at the top of the screen, top left-hand side, we see the best offer to sell is the offer that has the lowest price. The best offer price is 45.10 for 25,000 tons. Above that is 45.25 for 5,000. The highest offer price on the screen is 48.90. The inside market is where the best bid meets the best offer. This market is 45 at 45.10. There's a 10-cent spread between the bid and the offer. Right? So this is where the next trade is likely to occur. Now on the right-hand side, we see that trades have transacted. All right? Historically speaking, the most recent trades are at the top. That's the last trade. The last trade was 45.12 for 10,000 tons. The oldest trade on the screen, all the way at the bottom, 48 for 40,000 tons. Now you can tell a number of different things by just looking at the screen, even if you decide not to transact. What can you tell? Well, the first thing you can tell is that there's a healthy number of bids to buy and offers to sell. How do I know that? Well, there are multiple bids and there are multiple offers. It's not always like that. Sometimes there are no bids and lots of offers. When that happens, when there are no bids to buy and lots of competition to sell, what do you think happens to that marketplace? Well, it's likely the price is going to fall. Conversely, if there are only bids but no offers, if all people want to buy, a lot of people want to buy, but nobody's willing to sell, what do you think happens to the price there? Well, the price is probably going to go up. So let's look at what's happened to this particular market by looking at the trades on the right-hand side. What's been going on in this marketplace? Well, the last trade was 45.12. You see some other trades as your eye goes down on the right-hand side, 46, 47, 48. What's happening to this marketplace? Well, by the looks of it, it seems like the price is falling. You can tell a lot of information just by looking at the exchange, information that you can use in terms of pricing your own bid, whether it's for the exchange or for the auction. So we have an opportunity to reduce emissions by implementing controls at the beginning. We can participate in the auction, 4 different auctions. We can participate in the exchange. The exchange is always ongoing. There are a number of different kinds of orders that you can use in the exchange. Let's talk about a few of them. The simplest order is a market order. The market order requires you to pick a product, year 1, 2, or 3, and a volume of allowances that you want to transact or offsets you want to transact. You don't pick the price. You know the price is trading around 45, 46 pesos. You think that's okay whether you're buying or selling. Then simply select the product, year 1, 2, and 3, and the volume. And you'll probably transact around the last done transaction price. If you want to increase the probability that your order is going to get filled, make sure you click partial fill. That means that your order can be filled with a number of different smaller orders from counterparties that offer competitive prices. For example, if I want to buy 10,000 tons, and if I don't click partial fill, the only counterparties that I can be matched with are those who are offering exactly 10,000 tons of the product I want to transact at the price that I want to pay. Right? But instead, if I click partial fill for my 10,000 ton order, I can fill that order with the lowest prices that are being offered for sale, say 5,000 from party A, 3,000 from party B, 2,000 from party C. That's likely going to give me a lower price. So click partial fill. You also have a limit order. A limit order allows you to set a minimum sell or a maximum buy price. It says, you know what? I want to buy 45,000 tons of allowances. I don't want to pay a penny more than 50 pesos per ton. If I do that, if I select a limit order, I can make sure that I'm not going to be matched with anybody who's going to try to sell these allowances at a higher price. If the market moves beyond my 50 pesos, I won't transact. On the sell side, if I want to make sure that I get a minimum price, I want to sell my allowances for at least 65 pesos per ton, I'm going to put a limit order price of 65. And that way, if the market falls below 65, my limit order won't be filled. So there are a number of different other kinds of offers and bids and orders that you can put in. But let's move on to the next opportunity for you. Remember, you can abate in the beginning. You can participate in 4 government-sponsored auctions. You can participate in an exchange that's always ongoing, or you can do an over-the-counter trade. Over-the-counter trades involve a single buyer and a single seller. For these OTC trades, you need to specify the product, the price, and the volume. You can do these OTC trades anytime with anyone else in the room. Here's the way the simulation works, though. Only sellers can submit OTC offers. If you're a buyer and you want to transact, you got to use your voice. You got to speak up. Tell somebody else in the room that I'm short. I want to buy. I'm willing to pay 45 pesos for 10,000 tons. Is anybody willing to sell me that volume at that price? You need to use your voice. But you also, if you're a seller, you also need to use your voice and say, I'm a seller. I'm long. I'm willing to sell this volume that I have, 5,000 tons, at 46. Anybody willing to buy at 46? And then you have to negotiate back and forth. It's a traditional transaction. It's much less efficient than the exchange marketplace or the auction marketplace. And here's another difference between those other markets. When the auction and the exchange, you're going to likely transact with both humans and bots. In the OTC marketplace, you're only transacting with your other students or the other colleagues in the room or elsewhere who are signed on to the system. So your objective in this carbon simulation is to manage your operations given a number of different challenges. Your emissions, your BAU, business as usual emissions, are going up. Your allocation is going down. Your allocation of allowance is going down. Your BAU emissions are going up. So there's a shortfall that you have to solve for. And your goal is to solve for that shortfall at the lowest possible cost. Before you started the simulation, you were also given a cheat sheet. It tells you how Carb0n works. It suggests a couple of different strategies. It also defines some key terms for you. You might want to keep this cheat sheet handy by your side as you go through the process. In this simulation, I've designed it as the administrator. There's a cap, about 356 million tons. This simulation includes 3 years. Each year is about 20 minutes long in duration. There'll be about 242 different enterprises, of which 38 are going to be humans. The balance are going to be AI-driven bots. In this simulation, the reduction target is 9%. There's going to be a 3% reduction in allocation per year, right? But your BAU emissions are going to go up between 2 and 6%. Your business as usual emissions are going to go up. So there's going to be an ever-increasing gap over time. You can bank allowances as well. 100% of your compliance obligation you can carry forward. If your compliance obligation is 1 million tons, if you have to surrender 1 million tons at the end of the year, that's your compliance obligation. That means you can take 1 million tons into year 2. Back to the share of allowances. Remember, you're starting short. There's a 10% shortfall here. You have 90% of the allowances that you need to operate. You also can use offsets in this simulation. Offsets, remember, are tons of emission reductions that are created outside of the cap-and-trade program, right? You can satisfy 10% of your compliance obligation with offsets. In other words, if your compliance obligation is 1 million tons, you can use 100,000 tons of offsets to satisfy your compliance obligation. The rest have to come from allowances. In terms of auctions, there are 4 auctions per year. The auctions last about 2 minutes and 15 seconds. There is a floor price in the auction. You cannot submit a bid for less than 100 pesos or one greater than 300 pesos. You will be able to buy current and future allowances through the auction. There are different allowance vintages offered in each auction, auction 1, 2, 3, and 4. There is a penalty. If you end the year short, it's going to cost you 300 pesos per missing allowances, and it's going to cost you 1 allowance from next year. So if you end up year 1 short, 1 allowance, I'm going to take away 300 pesos out of your account, and I'm going to take away 1 allowance from year 2. Don't end the year short. There also is a volatility management limit of 10%. That is, in the exchange, if the last trade cleared at 100, you can submit bids in within 10% of that or offers within 10%. So make sure that you look at the last transaction and you make sure that your bid or offer is within that 10% band. If you don't submit a bid that's within that 10% band, the system will reject it. To win in this simulation? Well, to do well, you have to comply. Make sure you solve that shortfall. You need to manage the cost of control. All right? Reduce as much as possible what you're spending to solve that compliance shortfall. Abate early. Put on controls early in year 1 or don't do it at all. It's a waste of money if you put on controls after that when we're just running a simulation that's going to take 3 years, 3 virtual years. You should participate in all of the markets throughout the simulation. Understand that the prices may be similar in the auction, the exchange, or the OTC market, or they could be very different. It's not a perfectly efficient system where prices are the same between all different options. All right? Participate in all of the markets. Try posting two-way markets. What's a two-way market? A two-way market is when you say, you know what, for me, I am willing to buy allowances or offsets if the price is low enough. Conversely, I'm willing to sell allowances if it gets higher. So I'll post a bid at a low price and an offer at a high price. And I'm happy if it goes either way. So try posting two-way markets. Manage your long and your short position. You're long if you have more allowances than you need. You want to end the simulation with a zero long-short position. You don't want to have any surplus allowances. You want to have just enough to comply. If you have allowances at the end of the simulation, that means you've wasted money. So make sure you manage your long position, sell your surplus, certainly by the end of the simulation, but think about how much you want to end each year with. Your short position is when you don't have enough allowances. Make sure you don't end the year or the simulation short because it's going to be very expensive. 300 pesos a ton plus 1 ton debited from next year. Your orders are good until they're canceled. The simulation is kind of cool because you can submit orders in multiple different markets. And you can have multiple orders in the exchange as well as the auction. But until they're canceled, they're actionable, which means that they can be filled. So if you submit multiple orders, understand that, in fact, they could be filled. And that if you're not happy with the results of that, then you should probably cancel them. Don't make finger mistakes. And be patient. What's a finger mistake? Well, if the buy button is right next to the sell button and you accidentally press buy when you meant to press sell, you're going to end up buying those tons. That's a finger mistake. It happens all the time in the real world. And here's another thing. The system is not financial grade. This is not a Wall Street company that's providing you with an opportunity to participate in the simulation. All right? You need to be patient a little bit. If the system doesn't respond automatically, then give it a second before you press enter again. Because if you press enter once, twice, 3 times, you will have put in 3 different orders. Your choices and your actions or your lack of actions will have consequences. What you decide to do, that's going to define the outcome of your company. If you end up making smart choices, you're going to do well. And I'm confident that you will, in fact, make smart choices. Here's your objective. I'd like to see you finish this simulation, these 3 years, with an overall compliance price of between 30 pesos and 83 cents and negative 4 pesos and 12 cents. 30 pesos and 83 cents, that's a high price. That means that you're spending, the marginal cost of control is about 31 pesos. However, if you make some really good choices, I think you can end the year making money to the tune of 4 pesos and 12 cents. This is what the bots did. I think you can probably do better. In this segment, I'm going to take you through the process of logging into Carb0n Sim. Before we start, there should be 1 laptop per team. It'd be great if you have a partner that can be on your team. So 1 laptop per team. I need you to close all of your other programs. Find the Wi-Fi and sign on to it. Open your browser. It's better if it's Firefox or Chrome. Explorer works as well, but Chrome and Firefox are probably best. Then I need you to go to carbonsim.org, or if I tell you otherwise, sim2.carbonsim.org. I need you to go to the register page, not the login. Then on the right-hand side, the register page, enter your username, which is going to be your first names. So if there are 2 members on the team, put your first 2 names. Pick a password that you can remember, and then enter the PIN. I'll let you know what the PIN is before you start. This is what it's going to look like. Log in on the left-hand side, register on the right. The access PIN, that's the top of the screen. The first 2 names, player name. You're going to enter in your email address. Pick a password that you can remember. Under the company name, pick a company name that sounds good to you. Scroll down the screen, you can pick anyone you'd like. Then tick on the I accept the terms, and then register. Now you're ready. Let the games begin. This is where you're going to use all of that information about emissions trading systems, about how Carb0n Sim works, and you're going to manage your own company, a company that has a shortage of allowances. Your mission is to comply at the lowest possible cost. That's it. You finished. You have managed a company through some very challenging circumstances. You started out with emissions that were greater than the allocation. You started out never having seen the screens at all. You didn't know anything likely about cap and trade or how to manage a company subject to a cap and trade program. You figured out how to define the problem, the shortfall. You figured out that you had some limitations. You had a carbon budget limitation and you had a financial limitation. You figured out that you had a number of different opportunities to reduce your emissions and to solve your compliance shortfall. You looked at your marginal abatement control cost curve. You saw that you had choices to make, some of which were really smart choices based upon the cost of the technology, the time frame for implementation, as well as the marginal cost of control. And you saw that some technologies made sense, others didn't because of a number, whether it's the cost or the time frame. You looked at the auction. You figured out what was being offered in the auction, the different vintages of allowances. You saw the last trades that were being posted, and you said, I think I'd like to buy allowances at a price that makes sense to me. Right? You saw there were 4 auctions. You figured out how to develop a bidding strategy that made sense for you. You also were able to look at the exchange, and you said, you know what, while the auctions are going on, after I've finished doing my abatements, I can always go to the exchange. And you saw that there were bids and offers. You figured out what the best bid was and the best offer to sell. You looked at the historical trades. You saw where the market was trending. You figured out what a market order is, what a limit order is, and a stop order is. You saw how to use a partial fill order. You figured out how to do over-the-counter trades. Fun, right? But not very effective or not very efficient for sure. Right? At the end of each year, you were able to see how you did for your company, whether or not you complied and what your compliance cost was. You saw by looking at the leaderboard how you did relative to other players. Right? And you saw by looking not just at the leaderboard, but at the system report. And you saw the environmental reductions that were attributable to your actions, your colleagues, your friends, as well as the bots. You saw the emissions that were reduced through year 1, 2, and 3. You were able to take a look at this and see, you know what, I see what the allowances cost. I see that the offsets were costing. I see the monies that the government collected. And I thought about how the government can use these monies to address their carbon objectives, their social equity objectives, their energy objectives. And I thought about how these design parameters can affect the outcomes. All right? So congratulations. You finished. You've done really well. And hopefully the next time you take a look at Carb0n, you'll say, I'm going to try something different. I made some mistakes last time. I'm going to learn from what I did. And I'm going to take those lessons learned and put them into my next strategy. That's what we want you to do. That's what policymakers have done around the world, and companies that are subject to cap and trade programs who have participated in Carb0n. Learn these lessons, take them out, understand that the system that you have an opportunity to design and participate in should be one of your own making. And when you do that, you'll get results that are delivering on environmental and economic, social equity, energy, health, morbidity objectives that you wanted to address before you'd said, I wonder how I can solve this problem. Maybe I should do it using a cap and trade program designed in accordance with my personal objectives. Thanks very much for participating in Carb0n. I hope you have a good time and that you'll learn from this discussion. Please do let me know if you have any questions. I look forward to seeing you again. Thanks.